Hello viewers, you are watching Engineering Science presented to you by Progress MK. Alright, today's question: what is the direction of flight to reach the destination? From the following statement, which says, an aeroplane flies to its destination 300 kilometers east of its starting point and wind blows northeast at 10 meters per second. The pilot wants to complete the flight in 50 minutes. All right, so if you want to give it a try, you can give it a try. Just pause the video, then try it, then open the video after and watch for the solution. All right. Okay, and please, let's not forget to subscribe for free on this channel after watching this video for more videos to come. Okay, guys, let's get started. The first thing is to know the compass points. We have to know our compass points, which is northeast, southwest. All right, so we need to know our compass point, which is northeast, southwest. All right, and also to know that when they say the direction is northeast, it means it lies in between north and east, making an angle of 45 degrees. That is what it means. Okay, northeast direction. Yeah, that is what it means. Okay, so now let's now check on our question here and see what we have. We are told that from the starting point to the destination, there is 300 kilometers. So we need to represent that. We have 300 kilometers from the starting point to the destination. And we also have wind which is blowing at 10 meters per second northeast. Remember, the angle northeast angle, we say the angle is 45. So we have wind that is blowing at angle 45. And the velocity of that wind is 10 meters per second. All right, so that is the information we have there. And when you look at the first question, they're saying calculate the direction of the flight, because they know that even if the destination is east, you're not going to fly directly east because of the wind which is blowing. The wind has got an effect of pushing the plane, and we end up missing the destination. So we don't want to miss the destination. That's why we have to react to the wind. How do we react to the wind? We have to choose a direction that when the wind pushes the plane will end up facing where the destination is. So if we can see the wind is blowing northeast, so it would be wiser for the plane to take a direction which lies in the region of southeast. So which means we just have to know that the plane will go in the southeast region. All right, but we're not yet sure at what angle is it going to lie in that southeast region, at what angle. That is the direction that we have to calculate. That is our first question. Anyway, so now we need to close this triangle using the velocity of wind blowing here, which is 10 meters per second northeast, as you can see. All right, so let's now show the angle for the direction of plane. The angle, let's say the angle is theta. So we are using theta to represent the direction of the flight. All right, so we know that the wind direction is northeast, which is 45 degrees, remember. So which means wind is blowing at 45 degrees. Okay, so far that's what we have. And the velocity of that wind is also 10 meters per second. So we have 10 meters per second. All right, but when you look at the information that we have on our triangle, the other side is represented as displacement. The other side is represented as velocity. You can see we have 10 meters per second, which is velocity, and we have 300 kilometers, which is displacement. We cannot mix displacement and velocity on one triangle. So which means these 300 kilometers I can choose to change and find what is its velocity there, which is also the resultant velocity. How do I do that? There is a formula that we are going to use. So we say to get the resultant velocity, we use this formula. So our resultant velocity, I'm going to say resultant velocity VR is equal to displacement over time. That is the formula that I'm going to use. So now my resultant velocity will come as, okay, my displacement, as you can see, we have 300 kilometers. We change it to be in meters, we multiply by 1,000. So 1,000 meters over now time, remember we have time which is constant, 50 minutes. Time is 50 minutes. Time for the flight, which is time for the whole journey, is 50 minutes. It's not going to change. All right, so we are going to convert this time to seconds. So we say 50 multiplied by 60 to convert it to seconds. All right, so now the outcome of our resultant velocity is going to be 100. We're going to get 100 meters per second. So we have our VR now here, VR on our triangle, which is 100 meters per second. So now, so far so good. We can see that now we have these two sides represented with velocity. So now we're now going to look at another variable we can use to represent the velocity of the plane, which we can say velocity of plane, let's call it VA. So which means we have VA, which we still need to calculate. So we know that once we calculate VA, it will be now possible to get the direction of the flight, which is indicated as theta on our triangle. All right, let's now do it. So to get VA, this is going to be cosine rho. As we can see that we have the angle which is opposite to that side VA. So, and also we have adjacent side which are represented by the velocity. The resulting velocity 100 meters per second and the wind velocity which is 10 meters per second. So we use cosine rule. So we are saying VA is going to be square root of what? Of 100, square root of 100 squared plus 10 squared minus 2 multiplied by 100 multiplied by 10 multiplied by cos 45. All right, so that's how we are going to calculate our the velocity of the plane. Okay, so now when you punch this on your calculator, you are going to get 93,198 meters per second. All right, so that's the answer of our velocity, the velocity of the plane. So now let's now conclude. Now we need to calculate the angle theta now. So we now have all the sides on our triangle, vector triangle. So now we need now to use this information to calculate the angle theta. So to do that, we are going to use sine rule. To conclude, we say sine theta over the side which is opposite to angle theta, which is 10 meters per second, as you can see on our triangle, is equal to sine 45, and over the side which is opposite to that angle 45, which is VA, which we have calculated just now, and it's 93,198. All right, so when we solve this sine rule for theta, we can see that theta is equal to 4,353 degrees. All right, so that's the theta that we are going to get after solving that expression of our sine law. We get theta as 4,35 degrees. All right, so now we now have information that we can use to conclude our calculations. So now let's just have a space here where we can now final answer all the questions. All right, so I'm going to answer those questions here. So the first question, they said, okay, the first question, they said direction, which is 2.1. So which means now I'm going to now give the direction of the flight. So as you can see, if I go back here on my triangle and put compass points on the starting point, you can see the direction that we have there. So I'm going to show my compass point as usual. So you can see that the direction of the flight is lying in between south and east. Is in the southeast region. So, and is touching east line. Okay, the angle theta is touching east line. So we are going to start by east, by saying east, since it's touching east line. Then we call that angle. It's 4,35 degrees towards what? Toward the south. As if we're going to south. So that's it. So that's the first answer we get. We have answered first part. So that is our first answer. So now let's go to second question. Second question, they are saying calculate what? The velocity of the airplane in kilometers per hour. Already we have the velocity of the airplane, but in meters per second. As you can see, we have VA, velocity of the plane. That one, which is in meters per second, is 93,98 meters per second. That one meters per second, we just have to multiply it by this ratio, which is 3,600 over 1,000. This is 3,6, as you can see. So we multiply that, we are going to get 33. When you punch your calculator, you can also get this 335,513 kilometers per hour. All right, so that is the second answer that we have, which is what they're asking for. So yeah, that's it on this question, guys. That's it. So we always have to remember that if there's wind blowing, the wind is going to affect the plane and it's going to push the plane to take a certain direction. So we need to quickly react to that effect of wind so that we won't miss our destination. So that's it. All right.